In this video, we're looking at the problem a monatomic ideal gas has a pressure of 200,000 pascals and a volume of 2 meters cubed. The pressure of the gas is cut in half through an adiabatic expansion. What is the new volume of the gas? Alright, let us look through the problem for important information. So we know that the pressure is initially 200,000 pascals and the volume is initially 2 meters cubed. The pressure is then cut in half, so we need to take our original pressure and divide by 2, so 100,000 pascals. And we're looking for our volume. We also know that the gas is monatomic and that the expansion is adiabatic. Now we don't know what the temperature of the gas is, which means we can't use the ideal gas law to solve this. But I do know that the expansion is adiabatic. Now we're not working with energy in this particular problem. There's no mention of energy, which tells me I need to use the relationship P1V1 raised to the adiabatic index equals P2V2 raised to the adiabatic index. So the first thing I'm going to do is find my adiabatic index. So I'm going to take the molar specific heat at constant pressure over the molar specific heat at constant volume. So since this gas is monatomic, Cp is going to be 5/2 times the ideal gas constant, and then the molar specific heat at constant volume is going to be 3/2 times the ideal gas constant. So that reduces to 5/3. Alright, so now I can plug in my values. So I'm going to take my 200,000 pascals times 2 meters cubed raised to the 5 divided by 3. And that's going to equal 100,000 pascals times my unknown raised to the 5/3. Alright, so let me get out my calculator. Alright, so I've taken the 200,000 times 2 raised to the 5 divided by 3, and remember only the volume is raised to the adiabatic index. The pressure is still raised to that understood first power. That gave me the 6.35 times 10 to the 5, and then I divided that by 100,000 to get 6.35. So now I need to get rid of this 5/3. So let me write that a little bit better. Now to get rid of a fraction like this, we need to raise both sides to the inverse fraction. So I'm going to raise this to the 3/5. So 5/3 times 3/5 is equal to 1. So that gives us the first power. And then I'm going to raise this side to 3/5. So I'm going to take 6.35 raised to the 3 divided by 5. That's going to make my new volume a little bit over 3 meters cubed. So V2 equals 3.03 meters cubed.